9, 8, 7, 6, 5, 4, 3, 2, 1, engage!
Hello everyone. Today we are going to solve some application questions that related on vector fields, integral lines, and Green's theorem. Okay, let's get into the question. In electrostatics, the electric field lines cannot form any closed loops. However, in the electric field lines in electrodynamics form closed loops, which is entirely based on Green's theorem, such as the relation between integral and differential forms of Maxwell equations and energy of static currents. Therefore, by using Green's theorem, evaluate the following line integrals. So this is the line integrals given by the question, and where C is the triangle with vertices 0, 1, 0, and 1, 3. This is basically the loop that we need to draw after this, and we need to find the area of the loops by using Green's theorem. So before we solve these line integrals, we need to know what is Green's theorem. Okay, Green's theorem relates a line integral around a simple closed curve C to a double integral over the plane region D bounded by C. Okay, from this definition, we can see that on the left side, this is a normal line, simple line integral, which is like from this question, but we can relate the line integral into the double integral over the plane region D bounded by C. And basically, the Green's theorem, mostly the question that use Green's theorem is for the simple closed curve shape or situation curve. So we can see that there is L and M, which is LMS is function that has X and Y component. Yes, this is L, basically L, and this is M. We can also use another alphabet, which is P and Q or whatever. Okay, let's get into the question. Okay, this is the line integral given. First, we need to draw or sketch the graph first. So for this question, we just need to plot 3 points or vertices. It's 0, 0, 0, 1, and 1, 0, and 1, 3. And we can see that all these vertices, 3 vertices, we will get a triangular loops, which is we can use this Green's theorem to get the area of this graph. Okay, then let's use the Green's theorem to solve this. Okay, this is the Green's theorem, which is I use P and Q. Okay, from at the right side, we need to differentiate Q and P. We say for Q we need to differentiate it into over dx, and for P over dy, and we need to dq dx minus by dp dy, and dy dx. We also can use dy dx, but we will change the limit later. For first P square root 1 plus x3. If we differentiate it, we will get 0 because we need to differentiate over dy. So there is no y here, so it will be 0. And for q, we need to differentiate it on the dx. So we will get from 2xy, we will just get 2y. Then after that, both of these we will need to substitute it into the theorem, which is dq dx minus dp dy, which is 2y minus 0. But for the limit, we need to look into here. Since I use the dy dx, so we need to look the dy first. Okay, let's get back to the graph. Okay, from the limit of y is from 0 into the y equal to 3x. So we need to put it 0 into 3x And for x, we need to move from the left to the right. This is from 0 to 1. Then we put 0 to 1. And then we can integrate this. We integrate the dy first, y squared, 2y will turn into y squared, and substitute the limit, we will get 3x squared dx. Then we integrate for dx, then we will get 3x cubed. Substitute the value 1 and 0 into the equation. We will get, and the last value we will get 3.
Okay, Assalamualaikum. For my part, I will explain to you the second question of Green Theorem. So, you can see the equation they have been given and the equation for the graph. And then the graph will be like this. This is the parabola, first parabola, and this is the second parabola. This is their equation. And then the intersection part have been 1 to 1 and 0 0. Okay, and then this is the general equation for Green Theorem. Okay, from the equation, we have to put it as a, for the dx, we put it as dp, as p, and for dy equation we put it as q, and then their derivative we get 2 and 1, and then we put it in the green equation. So this is the from the above the graph, and then the equation, we can see that the limit, this is from x squared and this is third x, they are from here. So we can see I use from the lower to the upper and then left to right. So lower to up is, this is x squared, and the upper is y equal to x, and then from the left is 0 and the right is 1. We get this equation, and then the derivative we put it 2 minus 1 because we use it the counterclockwise. Okay, and then just simply use the double integration. We get y, and then insert in the equation, and then we integrate the from the above we use to get this, and then the last answer is 1/3. Just simple. You can do it as 1 2 3 and then get the answer.
Question 2. Find the value of a which fxyz equal to 2x squared y plus x squared zi plus xy squared minus x squared z j plus a xyz minus 2x squared y squared k is in the vector field of incomprehensible fluid with dimension f equal to 0. Answer. By using the division formula, we get that the division f equal to 4xy plus 2xy plus axy. Then we equate the answer to the 0. Then we will get a equal to -6.
Okay, Assalamualaikum and hello for all. Okay, my name is Muhammad Nur Bahri bin Baber. So today I want to share a solution for the last question. So the questions are given here. So now let's do it. Okay, for question C, given a vector field V xy equals to x relation of I plus to direction of J. So the question is determine curl V. So now we look at the solution. The solution is delta cross with vector field, where the delta is partial with respect to x, partial with respect to y, and partial with respect to z. So for the vector field, is given x for the I direction, 2 for j direction, and 0 for k direction. So now we find the determinant of matrices. So for I direction, we close for I column and row this. So we can see partial with respect to y times 0 minus partial with respect to z times 2 minus for j direction partial with respect to x times 0 minus partial derivative partial with respect to z times x plus for k direction partial with respect to x times 2 minus partial with respect to y times x. So we solve this operation. For I direction, partial derivative 0 with respect to y minus partial derivative 2 with respect to z is equal to 0, minus for j direction, partial derivative 0 with respect to x minus partial derivative of x with respect to z is equal to 0, plus for k direction, partial derivative 2 with respect to x minus partial derivative x with respect to y is equal to 0. So the final answer is equals to 0. Okay, for question 2 Roman, if V represent the surface velocity for the flow of river and based on the finding in 1 Roman, describe the motion of a floating leaf along the streamliness. So the answer is, we have then find the curl V is equal to 0. So we can say that the motion of leaf is flow through the river.